Hello, sixth graders. Go ahead and take a look at the bell work here. We're going to pause the video. And when we pause the video, you need to be writing in your assignment book the homework that is due on Thursday. It's the next set of class notes with the video. The video, again, is posted in Google Classroom, and you'll have to search for that document. It's that same one we've been using this whole last week, that class notes plate tectonics 6H document. And you're going to continue to work on that with the video. That's due on Thursday. Second thing, the homework that is due today is your plate boundary map activity. So you did either the map or a digital map. If you did the paper map, make sure your name is on it, either the front or the back, does not matter. And please hand it in to the teacher. If you did the digital map, I think the easiest way for you to turn that in is to take a screenshot of your map and email that to me. Okay, let's pause the video, take care of that, come back and hit play when we're all ready. All right, so we're going to go through the next part of notes here, and I want you at this point to still, if your Chromebook's open from turning in the homework, go ahead and close your Chromebook, because we're going to talk about the next type of convergent plate boundary. In fact, we're going to do the next two, but there's nothing for you to type in your notes in your document at this point. It's just you listening to the video here as I go through and explain it. So close your Chromebooks, make sure you're listening and paying attention. Your homework is going to be the summary table over convergent boundaries, and then you're going to move more into and talk about what the ring of fire is, because that's part of convergent boundaries as well. Okay, but right now, no notes. So just kind of pay attention here and listen as I go through these two types of convergent boundaries. So let's start with continental to continental. Let's take a look here at the picture. Again, it's a pretty simple picture, but I think it does a good job of illustrating for us what's going on and all the different possibilities. So obviously, it's two land plates colliding, continental crust, two continental plates colliding. So there's no water. They're the same type of rock. And while, yes, you might get a little bit of pulling underneath, for the most part, they're the same density. And so what ends up happening is, since neither is subducted, what ends up happening is they get pushed upward. And that's what this is. Neither plate is subducted because they're the same density. So both plates are pushed upward. And the result then are mountains. Right? And that's the big effect. Because the densities are the same, again, they get pushed up. These are not volcanic mountains. They're not volcanoes. They're just regular mountains with no magma or lava coming out of them. So the geologic activity that happens here at this plate boundary, that's the biggest thing. Mountains. It's mountain building. Again, we see earthquakes because we have plates colliding with each other in plate movement. So tension and pressure can build up, and when that tension and pressure is released, those are the forms of seismic waves and energy of earthquakes. So we can have earthquakes, mountain ranges. Like we said, there are no volcanoes. And that's because while, yes, there's a little bit of these plates being pulled under, it's so little that we don't even classify it as subduction. And so because there is no subduction, we're not creating any of the pathways for magma and lava to reach to the surface. So no subduction means no volcanoes. One of the best locations to talk about where we saw this happen was the Himalayas, then the Alps. Here are the Himalayas. The subcontinent of India. When Pangaea broke apart, India was like Australia. It was just kind of like by itself as its own subcontinent. And it is one of the last pieces from Pangaea to reach to where it is in its current location. And it literally slammed right into the into Asia here, creating the Himalayan mountains. You had a convergent boundary right here. So I'm hoping on your plate boundary map activity on your map, hopefully you recognized and you saw red line for your convergent boundary where the Himalayan mountains were. Okay. There's the Alps. Same idea. Mountains created because of two continental plates colliding together. All right, so that one's pretty easy. There's not a lot of other stuff. Earthquakes, mountains, density is the same, so there's no subduction. Plates go up. Last one, oceanic to oceanic. Here's the picture again. Here are your two ocean plates right here. Don't worry about the land over here. Right here is where we're looking, the two ocean plates. Now, this might seem a little bit weird, but there is subduction with these because the plates actually are different densities. The older ocean plates are more dense than the younger plates. Older plates are more dense than the younger plates. And the reason for this has to do with not that it's a different type of rock, but what that rock has gone through. There's been so much pressure on top of that basalt, that ocean floor, that the older it is, the more pressure has been put on it over time, and that has caused it to become more dense, right? And so again, the older plate is more dense, so it gets pulled in and subducted into the mantle where it remelts and kind of like recycles it again. We're going to see a lot of the same type of geologic activity that we saw with oceanic plates when they collide with continental plates, because whenever you have at least one oceanic plate, you're going to get subduction. So again, we're going to see ocean trenches, these deep chasms where the plate's being pulled underneath. We're going to get volcanoes, but they're not going to be on the land. They're going to be creating actual islands. So volcanic island arcs is what they're called. You see them here. Talk about those in a second. And then, of course, earthquakes again, because as we see, plates colliding, it's going to cause earthquakes, buildup of tension and pressure. All right, so where are some examples of these? Well, notice we have the Philippine Islands, Aleutian Islands, Japan, Southwest Pacific Islands. Hawaii is not on here because Hawaiian Islands are not on a plate boundary. And we'll talk about those later on, but they are not part of these type of islands. That's not what formed the Hawaiian Islands. So these are the ones that, again, more so in the Pacific Ocean, more towards Asia, okay, but not actually on the continent. They're islands themselves that are off into the ocean. They are caused because of the ocean-to-ocean plate boundary and that convergent boundary. So hopefully you saw that as well on your homework, on the plate boundary method. You had convergent boundary there all along that part of the map of the Pacific Ocean that was closer over to Asia compared to the other side of the Pacific, which is by the United States. Okay. That got us through this. This is the chart then that will show up for your video on homework for you to copy into your doc. We're not going to do it now. That's part of the homework. And then you're going to continue and talk about Ring of Fire in your homework video. All right, so that's it for here. Let's go on to now the next activity in class today. All right, the next activity for you to work on in class is a worksheet that is summarizing through all of the different boundaries for plate tectonics. And so up here on the screen is a worksheet. I'm going to pause the video, or actually the teacher's going to pause the video, pass out this sheet to you, and then I'm going to give you the directions for this, and then what you can do if you finish this sheet early, one more thing that you can start today. All right, so go ahead, let's pause the video, pass out the worksheet. Okay, so first thing I want you to do is notice that on the worksheet, it gives you the pages in the book that you're going to use, pages 32 to 36, to help you answer these 10 questions. Don't forget the part here at the top. There are two written response questions, questions 4 and 5. I know you can't see them here, so just kind of listen. But for these two questions, there is not enough room to answer them here. So originally, the directions said to answer them on a separate sheet of paper. I just want you to turn it over, answer them on the back. Okay? Don't answer them here, not enough room, answer them on the back. Go through, use page 32 to 36 to go through and finish this. If you finish it before class ends, turn it in. If you don't finish it before class ends, it is not homework yet. The homework are just the notes. You'll have to do it eventually, so if you want to use your book at home and finish it, you can, but it's not due in the next class, okay? If you do finish this, let's talk about what else you can do before class ends. You can start the next activity, which is a summary activity that we're going to be working on, so let me show that to you here now. Okay, I have this Google drawing in Google Classroom for you, and it is a graphic organizer. It's a web that goes through and organizes all of this information because, like I've said from the beginning, it's not that this stuff is hard to understand. It just is a lot of it. Look at all of it, right? When we went through convergent boundaries, I said, again, it's not hard. There's just a lot of it. Look at all of this down here for convergent boundaries. So I already have it set for you where you're just going to go in and you're going to click in the box and you're going to type in certain things. So for instance, let's focus here under convergent boundaries here for a second. These are blank because there are 3 different types of convergent boundaries. So you would write those in here. And then you're going to say, this says examples. I know it's hard for you to see right there, but it says examples. So you'll give examples of where we see that geologic activity and that type of boundary. You describe how the plates move. And then the geologic activity, you'll put in there like what's happening, volcanoes, mountains, earthquakes, whatever it might be. And so you're typing in every one of these boxes except you're not typing in any of the green boxes. Those are just the headings for you. Convergent, divergent, transform. Now, we haven't gotten to get transform yet, so you might not be able to answer this yet, and that's okay. I'm guessing that with the amount of work that I'm giving you, you might not even get to this today, and that's all right. If you do finish the worksheet and you have time, start working on this. You can still use the book to help you, and you can start filling this out. Use your notes to help you. And then we'll work on this more in class next time. All right, so just remember, homework is just the notes. It's not any of these last 2 activities, the worksheet or this graphic organizer. This is just stuff that we can work on here in class since I'm not there today and give you a chance to get started on some things. All right, work on your science stuff. Make sure that you're staying on task to complete everything that I want you to get done today. Have a good day, and I will be back, and I'll see you on Thursday.